An interesting security measure is the so-called MultiSigWallet. That's where you, instead that you have your normal MetaMask wallet, you have a wallet which is actually built within a smart contract, and it gives you actually kind of new possibilities. And I've made a long list of things you could do. What you could do is that you, for example, require multiple signers for a transaction, or that you do a time lock on transactions, or that you have whitelist, blacklists for transactions, and actually lots of other things. So basically just automate the address. Yeah, it kind of shifts, of course, the security, because the people who ultimately do the actions, for example, if you need one of three signers, then those three signers each need an address somehow, so they still need their own passwords. So it doesn't completely solve things, but it enhances it. Gnosis is one of the, has made one of those multi-sigs, which is used quite often. So here's sort of an example how that works. We have in here the contract, and that's doing stuff on the blockchain over here, all the kind of interactions, and that contract itself is regulated by the normal external accounts. So those external accounts, they actually tell this contract what to do, and then the contract over here does actions over here on the blockchain. So if you go to the site gnosis-safe.io, or with link before it for the test version, you get into the user interface. And what you can see over there, for example, the assets that you have, like the ethers and the tokens and that kind of stuff. So how does a multi-sig work? Here I've got a mini example to show the basics. What's actually done there, there's a split between the action that you want to do and the authorization of the action that you want to do. So here I've made a test function, and I've split here the action that we want to do, and I put that in the function prepare over here, and then afterwards I call execute, and the execute is actually doing the action. So for example, we want to call the function store with parameter hello. So we encode this and also take the address of the contract, and that's our own address in this case, and store is actually over here. So we put it in prepare here, and it actually saves the address, the function that we want to call, and the amount of ETH that we want to send, and it's saved over here. And then we call the execute, and then the execute is doing the real action. So it's taking here the destination that we want to call, the amount of ETH that we want to send, and the data that we want to send with it. And here it's just calling that function, and it's taking the results of it and checks if the result is fine. So by using this split, you can add all kinds of functions to this to make this more special.